Good morning. Welcome back. Today we're talking about physics, and I'll talk about physics today. We'll talk about physics. We'll look at Hooke's law. Today we'll talk about Hooke's law of physics. I won't take more than 10 minutes. I'll round up everything I think I should tell you about Hooke's law. Let us start. What's even Hooke's law? Hooke's law, it states that provided the elastic limit of an elastic material is not exceeded, the extension of the material E is directly proportional to the applied force. Mathematically, the force is proportional directly to the extension of the materials. Now, when you talk about Hooke's law, you basically look at elastic materials. Materials that are elastic. Materials that are elastic is what? Materials that are elastic is what we will focus or look at mainly. Materials like rubber, spring, mainly spiral spring, is what we look at. Okay, there's a graph used to express Hooke's law. Though apart from this question 1, 2, and 3, I will still take out my time to break it down and tell you, use these 3 questions to kill other birds under Hooke's law. So from Hooke, what he said is that so long as the elastic limit of a material that I call the elastic material is not exceeded, that material will still regain its elastic property. Then what if an elastic material loses its elasticity? That material will become plastic. It says that when it is being expanded, it will not return back to its original shape. So there's how I will extend a spring or expand a spring. It will get to a point when I remove the force causing such distortion, it will come back. But the limit I will expand that spring, it will get to a point what they call it when it gets beyond its breaking point. When I push it beyond its breaking point, it will not return back to its original shape, and therefore hence it will become plastic. Now, from what Hooke's law states, if I have force, if my force is proportionally to my extension, please, for physics, why solving questions work on physics? We work mainly with our fundamental units. That means that if a quantity is being given in centimeter, you convert to meter. Millimeter, convert to what? Meter. Meter is the only acceptable unit that we can work with. Unless and only if the option states that maybe in your option A, B, C, D, you are being given the extension in cm, cm, cm. So if I solve with meter, and if my options are in cm, cm, I have to convert my answer in meter to cm to get what is being required. So if it's objective and question, look at option A, B, C, D, and see their units. So it is mainly meter we know for distance, for length. But if, for instance, I'm working on theory question, please convert all convertibles. Convert everything to their SI units, to their appropriate SI units. So the force is in Newton. The E is what? The extension. If I now bring my constant, if I have F very proportional to E, if I bring my constant, which is the K, I have this. So therefore, force is in Newton. If I make K here, my formula, the Pascal formula, it will now become K equal to F over E. When divided by E, E cancel E, only K is now equal to F over E. Therefore, this K is my force constant. We call this K force constant. We call S the force. The force constant in Newton per meter. The force constant K is in Newton per meter. The F is in Newton, and the E is in what? Is in meter. So this is the units of the K. The K means force constant. This is number 1 thing I will let you know. The second thing we'll now look at now is the work done by an elastic material. There's a work done by the elastic material. There's also the force constant which we are asked to look for. But whichever way or whichever thing we are asked to find, please read the question, understand the question, and know what is required of you to do. Okay, if I'm to ask to now find the work done by the elastic material, I know work done W is equal to, I know work done, the work done I have is giving us work done W is equal to 1 over 2 KE square, or work done W is equal to 1 over 2 FE. These two formulas are used to find the work done by elastic material. Now, which formula will I use? See, there is no certain formula, so long as this is the call physics is concerned, there is no certain formula. The formulas you will use, is dependent on the question. So that means I'm not supposed to read and cram any question, number one. In fact, it's a taboo for you to even read and cram question in physics. Rather, read the question, bring out your parameters. It's from there you will know the right formula you will work with. Okay, when will I use this one? If a question is being given and they mention force constant K, I will use this one. Find the work done by elastic material, and in that question we are being given K. That is the first constant in the question. That means this one will not be useful. Then I say find the work done, and in that question they give you force. This formula will not be useful. See, from here also I can still derive and get plenty formula as the case may be. So your only function, your only problem is to know your fundamental quantities, how you derive accordingly, and how you can derive. You use this formula, substitute the other one, and get the other formula. The other thing you look at is this. Please, if you are good in mathematics, you are also good in physics, because they move hand in glove. So you need to know how to substitute your formula to get whatever you want. From here, still, you can do many things here. You can substitute F over E. So long as it's about Hooke's law and Hooke's law, you can substitute and then get whatever you still want to get. Now back to whatever I have now, please. Number one, how many centimeter makes 1 meter? 100 cm makes 1 meter. You have to know that. Whenever you are talking about Hooke's law, about elastic material, we look at centimeter. Whenever you have centimeter, convert it to what? Convert it to meter. Whenever you have millimeter, also convert millimeter to what? Millimeter to meter. For mass, if you have grams, convert your grams to what? To kg, kilogram. I've said that before. Now that's number one. How will I know my extension? Now, heat can cause different things to materials. When I apply heat on a material, mainly a metal, it can expand. It will expand. What is extension? A bar metal that was measured and found to be 2 centimeter or 2 meters, the case may be. If I apply heat on this particular metal and the metal finally increased to 2.5 centimeter, the extension is not 2.5 centimeter. What will I do? I will subtract the new length minus the old length. Whatever I now have, which is 0.5, it is not the extension. And the extension should not be calculated in what? Calculated in meter. In meter. We use meter, please. We use meter. We don't use centimeter as the case may be. Now, before I solve what I have on the board, I will, like I told you earlier, it's an online class. I am just my time is limited. If there's any question, you still type it down and ask me. I will reply you under. But whatever I am doing now, I will take my time to still use these 3 questions to answer problem of other questions. First of all, Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension of the material E is directly proportional to the applied force. And I have to put my force constant. A material can still regain its property only when a material can still become elastic only when it has not exceeded its elastic limit. Only when the limit has not been exceeded. That is when I can say this material is still elastic. Someone will not ask you the factor. Look at rubber. Rubber is elastic. Rubber is highly elastic, and in chemistry we are being told that we add sulfur to rubber to make it very tough. So the more the sulfur, the tougher the rubber, and the more elastic the rubber becomes. So, but whenever that particular elastic material loses its elasticity, it will be plastic. Number one problem. One. We are asked to find a spiral spring 15 cm long is stretched to this one. Initially it was 15 centimeter. This is the old length, and it was extended to 19.5 centimeter. That is the new length. From this thing now, by a force is equal to 15 newton. They might not say force, but they might put newton. That is force. So now, what is my extension here? My extension is now, when I say 15.5, 19.5 minus 15, I will still get 4.5. Look at my E. My E is equal to 4.5 centimeter. Like I told you, please always convert. Convert 4.5 cm to meter. I will say 4.5 divided by 100. So 1, 2. I have 0.045 meter. The force is 50. The extension is 0.05. The force is 50. And I want to get my force constant first of all. Before you start solving anything, please try and know what your force constant means. Try and find out your force constant before you keep solving. So what will my force constant here be? So if my F is equal to KE, my F is 50, my K I don't know, times my E is 0.045. Remember, I converted 4.5 centimeter to meter, and I got 0.045 meter. Number two problem. If the first length is in meter, second one is centimeter, please make sure they are balanced. Don't solve with cm and meter, is wrong. If this one is in meter, here should be in meter. Sorry for that. So if this one is in meter, if I have 15 cm and here is 19.5 meters, I can't use the two of them. I will convert to equal base. Meter or cm. So I divided 4.5 over 100 and I got 0.045. So if I to look for K, I divided by 0.045 divided by 0.045. It will cancel. Therefore, only K is now equal to 50 divided by 0.045. 50 divided by 0.045, it will now give me K is 111.11 Newton per meter. No Newton meter. Therefore, they asked what will be its length? What will be its length when extended by 100 Newton? Assuming the elastic limit is not decided. I'm still on the first question. What will be its length? What will be its length when stretched by 100 Newton? Assuming that the elastic limit is not exceeded. So what will I do next? Is to now find the new length. First of all, the new length now, E from here. So I'll be very fast now because of our time. From F equal to KE, here I have my E is equal to F over K. My F is equal to 100 over the K is 111.11. If I divide this, if I divide 100 divided by this, I get 0.09. I have 0.09. Look at my E, my extension. Therefore, the new length is not equal to what was our old length? What was our old length? The 15. Therefore, now the new length is now 15 plus 0.09, which is not equal to. I will now get 15.09 meter. Look at my new length, 15.09 meter. Thank you so much. This is all for number one. Then number two, as I rush number two work, I look at number two because of our time. I'm just very fast. A spiral spring of national length 1.5 meters extended by 0.5 is what will be it? First of all, F is equal to KE. F is equal to KE. Then the spiral spring, the length of this is this one is extended by this one. Look at the original length of it, or look at the extension of it by force of. Therefore, the force is 0.8. From what I have here, 0.8 force equal to the K I don't know. Then the extension is 0.045. 0.050 meter. Look at the extension. To find k, which I have to do, I'll divide it by 0.0050, 0.0050. Divide here, therefore only k is not equal to, I will now do 0.8 divided by 0.005 equal to 160. 160 Newton per meter. Look at the k. Therefore, I say what will be its length when the applied force is 32. Therefore, from F is equal to KE again, I'm asked to find the, okay, let me find my extension first. They asked me about the new length. Remember, it was 1.5, old length 1.5. So what will be its length? What the force is 3.2. The K I have is 160 times the E I don't know. Divided by 160, here by 160 to cancel. Therefore, only E is not equal to 3.2. 3.2 divided by the 160 that we got before. We got 0.02. Therefore, the new length is not equal to, what's the old length? The old length plus extension. So the old length was 1.5 plus 0.02. So it will now be 1.52 meter. This is all for number 2. Like I said earlier, please make sure you convert all convertibles. To get extension is not basically, I will not just say when I find the E does not mean the new length. The new length will not be the extension plus the old length. I will not get the new length. Remember I told you that if this is my metal rod, if it is of this length and I apply heat on it, it will expand. When it has expanded to this point, you notice one thing. You notice that the total length will not be the extended length and the old length all together. I will not just look at the old length as I will not look at the extension as being the total length. Okay, then the other one we have here, which is the last one, we are asked to find the work done. Work done, solution to number 3. If I have the work done, which I don't know, and the elastic material of mass is equal to 2,000 grams. 2,000 grams in kg is 2k. 2 kg divided by 1,000 to convert to grams, I'll get 2 kg. So what will if the extension E is equal to 0.54, and they gave me the A acceleration as 10 meter per second square in brackets, this I should find work done. Now I told you before I started that we'll have two formulas for work done. Work done is equal to 1/2 Fe, and it's also equal to 1/2 Ke square. Which one will I work with? I'll work with this one because this one I have mass. There's no force here, and there's no force constant. Number 1, look at this question. It's even what I have to even talk about more. There's no force here, and there's no force constant. Then what will I do now? Since there's no force and there's no force constant, but I have mass. Okay, that's okay. Work done is equal to 1/2 times force is now Ma times E. Force is Ma. I will not use this man because this man, there's nothing connecting force constant and this question together. So what will I do here? 1/2 times what's the mass? The mass is 2. I converted grams to kg, which is normal, times my A is 10, times what's my E? Extension is 0.54. So if I times up, 1 times 2 times 10 times 0.54, it will give me 10.8 divided by 2, which will now give me 5.4 joules for work done. Thank you so much. If you have any questions, you drop it down. I'll meet you in my next class. Thank you.